That's one quadratic. All right, so what we're looking at this time out is linear quadratic systems, which is a nice way of saying find the point of intersection between a quadratic equation and a linear equation, so a parabola and a line. Now, there is 3 different situations that can happen when these two interact. So I've drawn in 3 different parabolas here, 3 different situations. Now, the first situation, if I add a linear line here, so the blue line here is a quadratic. Whoops, how do I get my purple here? There we go. So here's a linear line. And what can happen is the line hits in 2 spots. So we have 2 solutions or 2 points of intersections. That's one scenario. The other scenario, well, there's 2 others actually, is I could have a line and it just hits the vertex of a parabola. And so I would have 1 point of intersection or 1 solution. And then lastly, the other situation that could happen is if I had a line and it doesn't even hit my parabola. So in that case, there would be no solutions. All right, so when I talk about a linear quadratic system, what we're looking at is the point of intersection between a parabola and a line. Now, here's the key, is an example number 1. I want to find the point of intersection between this parabola here, y equals x squared minus 10x plus 14, and the linear line, well, linear, it is a line if it's linear, y equals 7x minus 16. Now, when I teach grade 10 math, we do solving systems of equations, which is the point of intersection. And the key thing, whether you're dealing with 2 lines or a parabola and a line, is that the point of intersection is that these 2 equations are going to have the same x and the same y at the same time. That's what's unique about the points of intersection. They have the same x and the same y at the same time. And so if you get that concept in your head, is that when I have these 2 equations, is that at the point of intersection, so I'm going to go the POI, at the point of intersection, this y here and this y here are equal, all right? Now, I don't know what the x value is, but we'll get to that. But at the point of intersection, if these 2 y's are the same, that means these 2 parts are the same. And so at the point of intersection, therefore, x squared minus 10x plus 14 is equal to 7x minus 16. All right, so that's because, again, at the point of intersection, they have the same x and the same y at the same time. All right, so then I can make these 2 equal to each other. Now, what we have here, thankfully, is something we've dealt with before. It's a quadratic equation that we can solve. All right, now, again, no matter what method I use, whether I use factoring or the quadratic formula, because this is going to be in standard form, I have to get a 0 on one side of the equation. All right, so I got 3 things over here, 2 over here. So I'm going to move these 2 things over to the other side. And so I've got an x squared minus 10x. Now I want to write it in order, right? So now I'm bringing the 7x over. It's going to be a minus 7x. All right, I have my plus 14. Then I move my negative 16 over, so it's going to be a positive 16. All right, so again, I need to collect like terms here. And so I have x squared minus 17x. Put those 2 together, I have a positive 30x, or 30, sorry, equals 0. There, now I have my quadratic formula in standard form, so I can either, again, decide to try to use factoring or use a quadratic formula. I'm going to see if I can use factoring, because we just did the quadratic formula, but it might not happen, right? So again, the first term in the top left corner, my last term in the top right corner. And I'm lucky because this is a 1 in front of the x squared. So this is the easier one to factor, because x squared, 2 things that are going to multiply to give me x squared are always going to be x and x. Let's see here, though, 30. I need to multiply 2 numbers by 30. And yet, let's see here, so 215. Let's see here. So 2 times 15 gives me 30. All right, now doing the cross multiplying and then adding those terms up, I get 15x and plus 2x, which is 17x. I need a minus 17x. So I'm pretty close here because I got the right number, wrong sign. But watch this. I'm going to make this a -2 and this a -2. All right, or sorry, -15. So again, a negative times a negative will give me the positive 30. But now when I cross multiply, -15x minus 2x, that gives me the minus 17x. All right, so I can factor this thing. And so again, when I factor, I got my two pieces. All right, and let's see here. One factor is going to be x minus 2, and the other one's going to be the x minus 15. All right, and now to find the x coordinates of my point of intersection, I'm going to solve each piece, which is something, again, we have done, solving using factoring. We're just going to take a little bit further this time out because of the situation. Bring the -2 over to the other side, I get x equals 2. And bring the -15 over to the other side, I get 15. All right, now, what this is telling me, now I'm not done yet. What this is telling me is I have two x values. Situation number 1's happening. This line here is hitting this parabola at 2 spots. Now I know the x coordinates, but I do not know the y coordinates. So here's what I got to do. Because they have the same x and the same y at the same time, I can sub these values into one of these equations, either one, it doesn't matter, to find my y values. Now I'm going to pick equation number 2, even though I get the same answer because it's way easier. The y equals 7x minus 15. Way less work. All right, so I'm going to have to do that twice to find my point of intersection. So I'm going to call this equation number 2. Might as well put a number on it. And this is equation number 1. All right, so I'm going to sub x equals 2 into that equation number 2. And so therefore, I got y equals, instead of 7 times x, it's going to be 7 times 2 minus 16. All right, and again, I got y equals 7 times 2 is 14 minus 16. And it looks like my y value is -2. So that tells me now one of the point of intersection is 2, -2. There's one, but there's 2 of them. I got to do the same thing now with the x equals 15. I got to sub that into one of the equations. Doesn't matter because they have the same x and the same y. You get the same answer. But again, I'm going to go with equation number 2 because it's easier. All right, so now I'm going to sub x equals 15 into that second equation. All right, so therefore, I've got y equals 7 times x, which now is 15. Minus 16. All right, 7 times 15. Yeah, I don't have that one on the brain. Let's see here. 7 times 15. 2 15s is 30. Double that, you get 60. Oh, man, I'm just going to grab my calculator. Getting late in the day. All right, so 7 times 15. I got 105. All right, minus 16. And that gives me, 89. All right, so then the second point of intersection, my x value was 15, my y value was 89. So there is 2 points of intersection. All right, let's try one more of those. Example number 2, again, we got, here we go, a word problem. Gotta have a word problem. All right. Oh, another bird. Birds, squirrels, and balloons. All right. So there's our 3 situations. All right. So example number 2, a bird swoops down towards the ground to search for something to eat. All right, the height of the bird is given by the equation h equals, so here we go, example 2. So this is our bird. Here's its flight, which is a parabola. We have h equals 2x squared minus 10x. Whoops. Minus 10x plus 6. All right, so there's our bird. Now a bug, lucky for this bird, jumps from the ground at the same time with a height that is represented by the equation. So there's our first equation. Here's our second. This is the bug who has linear motion. Must be a powerful bug of 2x minus 12. All right. And the question is this: do the bird and the bug meet each other? And if so, after how long? All right. So, again, if they meet each other, they're going to have the same height at the same time. So those h's, if they meet, so I'll say at the POI, at the point of intersection, if they meet, those two heights are going to be the same, and they're going to do it at the same time. So the same h and the same x at the same time. So if these two h's are the same, that means these two equations are the same. So therefore, just like I did last time, 2x squared minus 10x plus 6 is going to be equal to 2x minus 12. And once again, we have a quadratic equation because our highest exponent is a 2. And so to solve a quadratic equation, no matter what you're doing here, I need a 0 on one side, so these two are going to move over. And so now I have 2x squared, so I'm going to write my x squared term first. I have a minus 10x. I got this 2x moving over, so I got a minus 2x. Now it's the numbers, so I got a plus 6. The minus 12 is moving over, so that's going to be a plus 12 equals 0. All right, again, I have to collect like terms. So I have a 2x squared minus 12x. And what do we got here? Plus 18. All right, so try to factor it here. So again, top right corner, I got a 2x squared, or top left corner, I should say, top 2x squared. 18 over here. Let's see here. So 2x, I got a 2x and an x. 18. Two numbers that give me 18. I don't know, 6 and 3. Try that. Let's see. 12x plus 3x is 15x. I need a minus 12x, not even close. And if they're not even the same number, so me putting the negative signs won't work. Let's switch them up. Let's go with 6 and 3. I need negative, so let's go negative, negative. Minus 6x minus 6x. Yeah, that works, right? That gives us the minus 12x. So once again, I could solve this by factoring. Got lucky there. So two pieces. All right, so my one factor is 2x minus 6 and an x minus 3. All right, and so now again, I'm going to try to find my x values. All right, so let's see here. Solve for x. I got 2x minus 6 equals 0. That's one piece, and then an x minus 3 equals 0. All right, so let's see here. First equation, I'm going to move the negative 6 over to the other side. It's going to be a positive 6. Divide by my numerical coefficient. And 6 divided by 2 is a 3. All right, so there's one solution down. Move the negative 3 over to the other side. I get x equals 3. I got the same answer, which means I only have one solution. So this bug and this bird, they do meet. They only meet once. So this bird better make the best of his opportunity here. So I want to know where they meet. So I'm only going to have one point of intersection this time out. And again, I got to take a step farther here. I'm going to sub x equals 3 into one of the equations. So again, it doesn't matter which, right? The number 2 is a lot easier, but just for kicks, I am going to sub it into equation number 1 because I'm going to prove it again with number 2 anyways. All right, so therefore, y is equal to 2x squared, so x is 3, so I get 2 times 3 squared, minus 10 times 3, plus 6. All right, let's see here. So now I've got y equals Bedmas. So I've got to do exponents. 3 squared is 9. 3 times 3 times 2. That's 18. All right. Minus 30 plus the 6. All right. Do some math here. Let's see here. I get y equals, let's see, 18 minus 30 is minus 12 plus 6, minus 6. And so therefore, the POI is 3, negative 6. But again, this is a word problem, so I got to analyze this. And if I read the question, the bird starts at a very big height. And so therefore, the bird, I guess, meets the bug after 3 seconds, 6 meters below its starting point. I'll put SP here because I don't have room. Starting point. All right. And again, just so I found out that the bug and the bird, well, the bird meets the bug, I would assume. So the bird started up at a height of 6 and swooped down and, well, not at a height of 6, but 6 meters below where it was. All right. Now, just lastly, if I had to substitute it into my second equation, I chose my first just to challenge myself. If you put a 3 in there, because that's where x value was, well, you would get 2 times 3, which is 6, minus 12. And again, you would have the minus 6. So that, again, just showing you that it doesn't matter which equation you substitute into. As long as you do the math, you're going to get the same answer. But in this case, we only got one solution. And it looks like our bird picked the bug up off the ground and then swooped back up. He got his lunch. So the bird, and again, if you put an if you put a time as 0 here, so that would be 0, and that would be 0. The bird started 6 meters up. It dropped 6 meters, got the bug, and back, had its lunch, and away it went. Much like we are going to do shortly. Well, we're not eating bugs, I hope.